I think I'm gonna start with the lecture itself. So it's gonna be about custom types, variants, and pattern matching in Motoko. So first little introduction, I'm Quint. I've been involved / interested in the IC since January, I think, 2021. And then I started when Genesis, the release was, I started also developing on it. So in my full time, I do blockchain development in general as a freelancer. I've also worked on Ethereum and other chains, but the IC still really excites me. So another at the bottom, you can see I've written a lot of Motoko packages by now, and they're all in the Aviate Labs organization on GitHub. So you can always check this out. You can also see at the bottom left of my slide, you can see slides can be found at motoko.academy. For people who are watching this recording later, I'm not sure if they're still going to be there after the bootcamp, but at least during the bootcamp, you can always go there and see the slides yourself so you can follow along. The reason being is that you can copy paste code out of my slides if you want to, just from the web. So let's get started. The contents are in order. I'm going to talk about custom types, pretty simple concept, which I think everyone knows in just every other programming language. A variant type, which most people might know as an enum in TypeScript, for example, and then a specific variant, which is the result type, and it's something you'll come into contact often while writing Motoko. And at the end, I'm going to talk a little about pattern matching, which can be an advanced topic. So if you don't understand everything from the beginning, if you're a beginner, it doesn't really matter. It will improve the flexibility in your code. Nothing much there. So first of all, prerequisites. I assume some things. So I assume you understand basic variables and types, how it works. That did the lecture about this. You can always revisit it. So basically, assigning values, reassigning them. There was another talk by Austin yesterday about switch cases and options. So I also assume you know these concepts. So an option, basically, you can see on line 1 here, is just it can either contain a value or be null. A switch statement is basically a way to check what the underlying type is. So in the case of an option, you can check whether in the first one is whether it has a type, and the second one is it's a wildcard pattern. You like ignore everything else that's not the cases that came before. And in this case, like it's null in an option. So I kind of assume you know this, since I'll just use switches like anything else later. But you can also always revisit it. So first of all, I'm going standstill with what types actually are. So first of all, the primitive types: float, integers, booleans, text, even blob binary data would be a primitive type. It contains a value on itself. And then I would differentiate in container types. So that's basically a type that contains other values. It can be other container types or primitive types. For example, the option we saw earlier, arrays, records, variants, which is one of the topics we're going to talk about a little more in depth. What is it actually? Tuples is also one. And then there is also the reference type. So in the context of the IC, you have actors, you have functions, and of course you also have principles. But we're only going to focus on variants in this lecture. So custom types, again, stepping back, pretty easy. I would describe it as a blueprint for types. So first option is it's just another name for a primitive type. So I can just say my text equal to the type text, but I can also make it a little bit more complicated than this. But I'm sure most of you, if you're like studied a little and done studied JavaScript, for example, you get used to creating out some types, and especially in TypeScript. So just to go over it, for most of you, it might be repetition at this point, but the second option of just what a custom type can be is a combination of container types and primitive types. So in the first example, we just have an array, which is an array of text, basically. You can go further than that. You can create a record, which has a tuple. You can even combine them. So you can have an optional record, for example. And these are, the sky is the limit at this point, but make sure you understand and can like combine all these different things and make sure to understand them, but because it's pretty important for the pattern matching part. So I'm gonna give an example. I want to describe a solid figure like a cube, a sphere in Motoko. What I would do is, okay, I have a color and it has a name. Basically, I think everyone can do this at this point. Now, I want to teach you something to prevent issues you might run into if you don't use them consciously. The custom types, or just types in general, is, for example, in this example, if we use the solid figure type above and we try to create a cube with the name cube, well, it's not of the type solid figure, of course, since it's missing the color. Motoko really expects you to fill in every field. It's not like in, I think, JavaScript and TypeScript, you're allowed to just instantiate object of a type without filling in all the fields. There will just be defined. Since Motoko is strongly typed, that's not an option anymore. So another thing I see often is, let's say I want to define a sphere, which is a name and has a name and a color, which is fine. Like it looks, yeah, it has all the fields, which is fine. So Motoko will be smart enough to know it's just, it coheres to the solid figure description, but it won't check it for you explicitly. So I would recommend to like always specify where you can the type with the variable itself, basically. Now, this is pretty straightforward until now. You might have already looked around a little in the base modules, the Definitive Foundation wrote. And there we can find two examples of these custom types. One of is list, which is a combination of an option and a tuple at the top. So an example would be this, how you would write it. Another one, a more complex one, is the try. And here, basically, this is my step to the next slide, of course. They make use of variants as a combination of like all the other concepts we talked about before. So what is exactly a variant type? So for people who are used to programming more, I would say it's an enum. It's probably the term you use outside. It's basically a list of different types, a variation of what it can be. I think the simplest example I could think of would be, okay, what type of day it is? Well, it's a fixed set, so enum's always fixed, and then, well, it's Monday, Tuesday until Sunday. Nothing else than that. So some example code, let's say I have a function that converts this enum to the string itself. What we basically do is what we saw with in Austin talk, we just use a switch on the variable itself, and then we can basically just go through. And the good thing is, so Motoko has pattern matching built in, and the compiler, if you're missing a statement, the compiler will also tell you, hey, you're missing one. It's not complete. So that's a good thing. At the bottom, it might be a little advanced. I also created a function that returns whether a day is a weekday or a weekend. And here I put in both the wildcard pattern, so it can be anything. I might need to reiterate the switch datum is always evaluated from top to bottom. So it's first going to try the first one, the second one, and so down. So in this case, if it's Saturday or Sunday, return that it's a weekend. And otherwise, it's going to be a weekday since we already checked for Saturday and Sunday. This is a fun mimic. I don't know a lot of people know about, but you can use an or in switch statement to like check for multiple things at the same time. So that's basically a variant type. I hope I explained it clearly, but it's not limited to only just have no value. So if I go back again, you can see here we have 3 variants. One is empty, one is a leaf, and a leaf also has a type assigned to it. A branch is then, of course, a branch type assigned to it. So again, the custom types is applicable here too. It can either be have no value assigned to it, or you can have values within them. So I think the most important variant type you need to get used to is the result type, which is also defined in the base package. And well, I described, and the documentation does the same, is a result type is a type used for returning and propagating errors. So basically, let's say you have a function and you want to return either the value, or if something went wrong, something unexpected, you might want to return an error that describes what went wrong. And the result type is basically destructured to do this. So if you return it, you can either return OK with an OK value. I use generics without like really standing still. If that's a concept you don't really grasp, it's basically you can dynamically assign types to these. So feel free to just take it over and assign them yourself. But this is basically a wildcard, so you can do it on the fly. So you either return OK and with your value, or an error message, which is, you'll see if you look at you're using maps, I think, from the base package. If you want to get a value and the value is not there, it's probably gonna return an option. So either the value or null. But the problem there is that you don't have any context why it was null. It didn't find it. Was there something else wrong? And that's basically what the result type solves. So the actual interesting part of the topic, since I think most what I said you figured out yourself, or someone else already mentioned it in another lecture, I'm gonna stand still a little bit with pattern matching, and on this slide especially subtyping variants. So what I mean by subtyping is basically this. So previously we defined day as this. So of course from Monday to Sunday. But what we can do is we can say, well, a weekday is Monday to Friday, and a day is either a weekday or it can also be Saturday and Sunday. And now we could say that weekday, this is the formal notation to say weekday is a subtype of day, since it's a subset of the whole thing. So day is this, and then a weekday, basically the subtype would only be this part. So again, here the two texts, I showed it in a little, but basically what I can do is I can create a weekday, which is a subtype of day, and still pass it to the function, since it's still enough. So that's might be a good thing to stand still and try to understand. You can always, again, I'm going to reiterate at this point during the bootcamp, the slides are available. So make sure to just open them up, save them locally so you can revisit this later. But it's a pretty good trick you can use. But of course, it only makes it easier to build complex systems. I see someone already raised their hands. I'm going to go to Q&A after, which probably will be in 5 to 10 minutes, not that much longer, and then I'll try to answer any questions that are there. So that's one type of pattern matching. Another one is, let's say I want to return a function of the following type. I put in an example that's not implemented. Let's say I want to return the sum if the three values I pass to it are not null. So for an example would be, I pass in 1, I pass in 1, and I pass in null. I expect it to return null, but let's say I pass in 1, 1, and 1. I expect it to return 3. So most of you, and I initially too, solved it like this. So what we see here is an implementation. So we basically leverage a switch statement to check what the underlying value is and extract it. So if we go over it together, this is, well, let's first check whether the first value is null. So we do a switch datum on the first value, and here down here, we say if it's not an actual value, it's not, if nothing is assigned, we return null. If not, we of course go into this part. So that's done. We checked whether the first one was not null. So we can just repeat the process. Okay, we can check the second. We do the same, return null if it's not, it has not a value. In the third, we can do it a little shorter in the sense that, okay, if the third is null, we return null, and otherwise, if it has a value, we just want to take the sum of them. But the problem here, and it's not wrong, the code is right, it does what you want it to do. The problem here is it becomes very unreadable if you try to nest a lot of switch statements inside each other. So there's actually a pretty easy workaround, and that's what I would be having version 2. Version 2 as another approach. What it does, it also does it one by one. It checks the first one. If it doesn't have a value, it's going to return null. Otherwise, so the return null here really returns out of the function. It like ends the function and returns it. In a switch statement, if you just put a return value, just a value at the end of a block, it's going to basically return it out of the switch statement. So if it has a value, we can basically catch this one in a new local variable, which we're sure of it's going to be a natural number since that's what we checked here. So it's not an optional anymore, it's going to be a number. And we just can repeat this for all three. And by the time we're here at the end, we can just use these local values we got out of the switch statements and return the sum of them. So I would say it's an improvement over the previous codes. Since now it's more linear, it's clear, okay, if this fails, we go out and then we just repeat. And you don't have like the nested structure anymore. But of course, one part of the talk was talking about pattern matching. And we've been doing it all along. Like the switch statement here, it basically pattern matches, in this case, that it has a value and otherwise we do nothing. So we've been doing it. But there is a power. There is nothing is telling us we only have to pass in one at a time. So for me, the ultimate solution to this question would be the third one. And you can see we started at 17 lines of code. We went to 16. And you can easily do it in 7 with clean code. So what this does is basically we just pass them in all 3 of them. And with pattern matching, we can check if the first one is not null, the second one is not null, and the third one is not null, then we're going to return the sum. Otherwise, we can just return null itself. So I actually already at my final slide. So I have some tips and tricks for you to leverage in your code if you want to. I'll go over them first of all. So one of the things that also can use pattern matching, or at least a form of it outside of switch statements, of course. So let's say I have a type ABC, which just has 3 values, A, B, and C, which I assigned here on the 3rd line. What I can do is basically extract values. Some of you might have been used to it if you write, for example, TypeScript. We can just ignore B and C and just get A. And if we would print A, we would just see the string A. So this is a nice trick to like keep your code very clean. The second tip I got is you don't always need to, in a switch statement, make a variable and then in the body check what it is. You can basically already tell like, okay, I want A already to be assigned to this string, and otherwise I want to do something else. And of course, here I'm, for simplicity, also ignoring B and C. Nothing is stopping you of actually doing that in this case. Another one to keep things short, since records are immutable if you don't use the var word, the term in front of them. So you basically, if you want to change a value, you have to rebuild the whole record. And the last thing is, well, pattern matching can make it easy for you. Let's say, again, we have here at line 3, the ABC with A, B, and C just assigned to A, B, and C. Well, what if I want to replace C with D, for example? Well, I can just say, I want ABC, all its values, but I want C to be D. And nothing stops you here also to like add multiple. So just with the semicolon, you can add like multiple override fields basically. And what's it gonna return is A being equal to A, B being equal to B, and C being equal to D. So this is a very easy way to make like copies of records with different fields in them. So this is all I got prepared for the lecture itself. So we can go to Q&A. Let me go open the questions here on my screen. I'll first do the written questions, and then I'll give people access to just ask them live. So first question that came in was, is a custom object type basically the same as a class? No. So it's a very good question. It's out of topic of the lecture, but so a custom object, which I use the term records a lot, right? And I did this on purpose, since you could say a class is the same as an object, but a record is not, meaning I'm not sure if we already got a lecture about stable variables and stable state. But a record by default is stable and a class is not. So there is a big difference from a memory perspective on that front. So basically, to keep it simple, is that classes you cannot pass to other canisters externally, but records you can. A follow-up question was, a record is like an instance of an object. Also not the case. So the main difference really is that an object just has all static fields and a class doesn't. It can have private fields and you can have multiple functions in them and such. So let me try to get another one. So there was a question, why not simply use, yeah, it's difficult to dictate, but with the question, I think it's referring to the example here. Why don't you check if N1 is not null, N2 is not null, and N3 is not null? The big reason being it's a good point, because in other languages, for example, TypeScript, you would do it, right? You can at the top just check, okay, if n is null, or n2 is null, or n3 is null, we can return null since we know it's not assigned, and otherwise we can summon. But the reason we're using switch statements is that you cannot directly get the value in an option. So if you have an option, you have to use a switch statement to get out the value this way. So we have to use them anyway. So that's basically why you cannot just check if they're not at null at the beginning and just sum them. You really have to extract them from the, basically this displays it. We're extracting the natural number from the optional natural variable. And that's what we need before we can sum them, basically. Tips and tricks has an error in the second block. That's possible. Case, yes, it does. It's not an error. So the comment was on line 3. We basically want to check whether A is equal to A. And you would think there need to be 2 equal characters here. This is not the case, since what we're doing here is basically describing the pattern and not doing a Boolean operation checking it's equal. So that's a big difference. Again, reiterating, this might be complex and sound like, what the hell am I talking about? I don't follow. It's pretty advanced and you probably don't need it. I just want to lay it on the table for people who are looking at like doing something like this. There are a lot of other questions. So how can I do pattern matching to find character spacing in text? That's a good question. So I think you're trying to refer to one of your challenges you need to solve. I can give a tip there. So you cannot pattern match on text immediately, at least not like check if there's a space in there. So what you will have to do is, I cannot solve it for you, but I would look at the base text package in which you can convert or search patterns that way. There is a function there that you can leverage to do this. There was a question from Wannes. I didn't got what the let A in equal ABC does in tips and tricks. It's not that, so we're referring to this line. It's not that substantial. The only thing is, let's say you have a function which accepts this type and you're only interested in A, you basically can easily extract it this way instead of needing to write abc.a to access the field directly. So this is just an easy way to rename them instantly with the pattern matching Motoko has. And then the final current question I have, and then after I'll look at people having their hand up. In tips and tricks, is the let A equal ABC Motoko syntax for object deconstructing? And as a question from Lee, yes, exactly. So it's a perfect term to put on it. It's deconstructing the object. That's exactly what this line here does. So I have 2 hands. And I'm going to give NFT collection first, if they still, let me check. Can I give you allowed to talk? So you're permitted to talk, NFT collection. So if you want, I'll give you 10 seconds to mentally prepare to ask it. And the other one, I think Dan also has a question, so I'll give him word after this. And I assume the question is answered, or? All right, let's go to Dan. So Dan, I think you are now permitted to talk.
Yeah, it looks like I'm unmuted. So
yes,
yeah,
I can hear you.
I thought it was very elegant the way you showed the different ways of doing the pattern matching in passing 3 distinct numbers. So there's kind of a fixed set of numbers that you're passing, and going from the switch case nested example to the 3 sets of and down to your elegant solution here, which you're displaying right now. What I'm trying to imagine is what would happen if you passed, instead of 3 distinct numbers to this function. Normally you'd want to do pattern matching on a large number, so say an array. What would happen? How would you imagine solving this if you were to pass, instead of 3 numbers, to pass an array? Would you then just traverse via a while statement, or how would you do that?
A very good question. So an array, I don't know where your question comes from, but if you use to functional programming, you also use pattern matching to like extract the first value, the head of an array of a list. So you can still take this approach with lists themselves, but if you really use an array, which in Motoko an array has a fixed type, you cannot do the pattern matching, since the compiler or the runtime doesn't have a notion of how long the list will be. So there is really no way to say, hey, okay, the first X amount of numbers are equal to this, I want to do something. So the actual solution you already suggested is sadly you have to iterate over them, and doing that way. There is, at this point at least, no easier solution than do that, to be able to do this with just a dynamic amount of numbers. So I hope that answered your question, but you already got the answer yourself. So
no, exactly. It's kind of what I imagined, but I was looking for this is it's really showing the beauty of Motoko. I mean, I'm new to it, but it really shows the value here. I appreciate your talk. It's been very clear.
Oh, thanks. Yeah. It's this is also the part I find the most fun, being able to like really elegantly solve some stuff with the pattern matching. It's nice if it works.
Yes, thank you very much.
Thank you for the question. Then I have another question, so let me move to Dima. Let's allow you to talk. Let me see. Dima, the floor is yours. Hi.
Yeah, hi, hello. Hope everyone is doing well. Actually, I've got 2 questions. First one is following the previous one. I'm very new to this, and maybe it's silly, but can I pass to switch like a hash map and navigate through the hash map through cases? Does it make any sense?
Yes, it makes sense. The hash map itself, you cannot, since a hash map, at least in a base package, is an object, which is not what I described as a static object. So it's not a record. That's the problem. So the only thing you can put in switch statements are stable structures, and a hash map in this case, at least from the base package, is not, since it's a class itself. But what you can do is, for example, do the hash map.get and put that in here. And basically what's going to do is then evaluate whatever the function returns. So it's possible to do it that way, but the hash map itself, you cannot pass into a switch statement. It would be possible, but I'm going maybe very advanced. If you look at this structure, a trie, which is a tree, which kind of can be used as a hash map behind the scenes. All these types are static in the way that they're not objects. So a trie you would be able to pass into a switch statement, since you can just statically see if it's empty, a leaf, or a branch. But the hash map itself from the base package, it's not possible.
Mm-hmm. Okay, and the next question is maybe outside of the scope of this lecture, but for example, is it possible to see current states of, like, let's say, like list of users? Where can I see it?
What do you mean by the list of users? You mean the people interacting with your canister, or?
Yeah, for example, I mean, we don't have a database, but we have current state which stored in WebAssembly page. And is it possible to see current state of objects in the system, instances, like records?
No, you'll have to like program it to expose it and save. I think there is no like inspection methods like you described that you can use.
Mm-hmm.
You'll
Okay.
actually have to program it.
Mm-hmm.
I hope
Cool,
that's
thank you.
answered the question, at least partly.
Yeah, cool, thank you.
Okay, thank you for the question. Let me check again. There are a few other questions. So, but Motoko supports mutable arrays. You mean the array type with a var as the subtype, right? Yes, that's supported, but it still won't work in switch statements, sadly. Another question was there another question? Actually, that's all the question, I think. So I'm gonna say goodbye if there aren't any more questions in the coming minutes. And I hope you at least picked up something, learned something, and are excited to experiment a little bit more with Motoko and try to find ways to reduce a function like this to a function that's a little shorter and, in my opinion, also a little more readable. So yeah, this will be it for the lecture. I wish you all good luck with the personal projects. And yeah, I'll see you guys in the Discord, and I'm looking forward to the results at the end of the week. Good luck, and see you all soon. The next lecture I'm giving is Saturday about Motoko packages, so you probably see me again. So yeah, time to stop the recording and end it. Bye, everyone.